Hello and welcome to Instructor Allison Online Tutorials. In this video, we are going to discuss resistor. And this comes under electricity and magnetism. So in resistor, before we solve this problem, we need to understand the concept of resistor. Resistor is the measure of the opposition offered to the flow of electric current. That is by definition. But again, if you want to understand more concepts about resistor, you need to know first how it is being connected. We have two ways it is connected, both in series and in parallel. But before then, we know that resistor is measured in ohms. That is, the SI unit of resistor is in ohms. Ohms is a unit. Ohm is a unit we measure this resistor, and this is a symbol of it. So if we want to draw the diagram for resistor, we have something of this nature. So this is the diagram of resistor. Some other diagram can be in this form. And with this, we can be able to, let's say this is point A to point B. We can be able to have a circuit of resistor to be in this format. Then maybe we have the source here, which here is a positive and here is a negative. Here is the source voltage, could be the EMF, the electromotive force, or the cells, right? And then this is the resistor. You can have other components, maybe the current that flows in this circuit. If you like, I have an ammeter too that measures the current that flows through the circuit. All right, this is a positive, telling us that this flows from the positive and terminates at the negative. So that is the basic understanding about resistor. So in this video, we are going to discuss resistor in series and in parallel. And the best way I can do that is to represent them in a formula. The formula for resistor in series is we having the algebraic sum, or we can have the equivalent resistor, or the total resistance of the resistor, which is R1 plus R2 plus R3 plus Rn, depending on the number of resistor given. So this is resistor connected in series, and resistor connected in parallel. Resistor connected in parallel has its formula to be 1 over the equivalent resistance, which is 1 over the inverse of R1 plus inverse of R2 plus inverse of R3 plus inverse of Rn, meaning depending on the total number of resistor or resistance given in the particular question. All right, this particular formula can also be summarized by looking for the equivalent resistance, and that will be, we need to look for the LCM of the denominator, and the LCM of R1, R2 and R3 is just simply R1, R2 multiplied by R3. All right, this R1 goes into this R1 can easily cancel out with this. What will be left is R2 and R3, and that multiplied by this one will give us R1 by R3 plus, if this R2 goes into this denominator, R2 will cancel out with R2. What will be left is R1 and R3. So we have R1 multiplied by R3 plus, if this R3 goes into this denominator, R3 will cancel out with R3. What will be left is R1, R2, and if that multiplies by 1, you will have R1, R2. Finally, this is 1 over the equivalent resistance. So if I want to get this equivalent resistance, I will have to invert this. And if I'm inverting the left hand side, the right hand side also has to be inverted. That is because of 1 over, which is the reciprocal or the inverse of this equivalent. So if this reverses, that is arrow equivalent will become, this will also reverse. So we have arrow 1, arrow 2, arrow 3, the product of those three, divide by arrow 1, arrow 2, arrow 3 plus arrow 1, arrow 3 plus arrow 1, arrow 2. So this is another formula you can easily use in solving problem that is involved or that involves resistance or resistor in parallel. And then use this formula, or you can still use this formula. They are the same thing. All right. So in this question, we're going to see if we can apply any of this formula. And the question says 5 resistances of values 0.1 ohms, 1.7 ohms, 2.0 ohms, 1.0 ohms, and 0.9 ohms are connected in series. So you pay attention to the instruction here. If it is said that these resistances are connected in parallel, then you should consider any of these two formulas I have introduced. But hence they said it's connected in series, then you consider the first formula that I have introduced. All right, so let's make away with these formulas. All right, so if we read through the equation again, we are asked to find what is the value of the combined resistances. That is to say, what is the equivalent resistance or the total. You can see sometimes we use arrow subscript T. That is the total resistances. And that is very simple. It's simple in the sense that the resistances are given already. 1, 2, 3, 4, 5. About 5 values. That means in this formula, we will have to extend this. That arrow equivalent equal to arrow 1 plus arrow 2 plus arrow 3 plus arrow 4 plus arrow 5. And we stop there because we have 5 resistances. So the best way to substitute this is just to put in this value there. And that will be easy and simple. Arrow equivalent is equal to, the first value is 0.1 plus, the second value we have there is 0.7, and the third value we have is 1.7. We have the next value to be 2.0. We have the next value to be 1.0, and then the last value we have there is 0.9 or 0.9. Therefore, arrow equivalent equal to, let's check the sum of all these values. We have 0.1 plus 1.7 plus 2.0 plus 1.0 plus 0.9, and the result to this is 5.7. So we have this to be 5.7. And what is the unit of resistor? That is the same ohms, and this becomes the result to this particular question. I hope this is simple. Notice that we applied direct formula because we see the instruction here that it is connected in series. So please make sure when you check in the question, understand it, and you can see the value of the total resistance when they are summed up together is more than the individual resistance or resistor values we have there. So if you understand this video or understand this lecture so well, please make sure, whether or not you understand, make sure you subscribe to my channel, turn on the notification, and please like this video and share. Thank you very much, and stay tuned for the next video.